the transfer of force to the parallel position. Now let us see what is this concept. If you see here in this figure, force F is acting at point A, and if I want to change the position of this force F from the A to B, and B is the point located at a distance D from A. Now how to change and what will be the procedure, and effect must be same. Effect must be same. This will be the condition. Now to proceed this, it will be advantageous to resolve the force acting at a point on the body into a force acting at the same other suitable point on the body and a couple. Now if you see here, what will happen? Here on the body, F is the force which is acting at a point A, and we have to replace this force from this position to B position, but condition is that the effect should not be changed. Now here what is the done over here? If you check it out, this figure number B, at point B there is the two forces are applied which having the magnitude F, same magnitude F, but one force is going in the upward side and another force is going in downward side. They are equal in magnitude but opposite in direction. It means that the summation of these two becomes 0. It means that one force is added, one force is subtracted. Okay, because these forces are equal in magnitude but opposite in direction. It means that whatever may be the effect which is produced due to this condition number 1, which is having the only one force at point A, and it is giving the same effect when we are applying the equal magnitude force at point B, F and F in equal in magnitude but opposite in direction. It will point A, F is the force, and at point B, this one is the another force. These two forces are equal in magnitude but opposite in direction and separated by some definite distance, and this is nothing but what? Your moment. And moment is nothing but what? Force into the distance between these two forces. That is nothing but what? M is equal to F into D. This couple moment will be acting at a point B, and the couple is, as we know that previously, the characteristics of couple, you may transfer or you may shift this couple anywhere, and we are shifting this couple at point B. That's why it will be producing the same effect which is produced in the figure number 1 as well as in the figure number 2 and as well as in the figure number 3. All these three figures producing the same effect as that of produced by the figure number 8. Okay, it means that if we are applying the force F as well as one couple moment which is having the magnitude of F into D, it will be producing the same effect that is produced at the figure number 8. Okay, this is the concept of transfer of force to the parallel position. Okay, now if you see here, now it is the it can be shown that the force F at A may be resolved into force F at B and a couple moment having the magnitude of F into D. Okay, what we have done, instead of applying the force F at A, we are applying force F at B and a couple moment M that is having the magnitude F into D, where the D is the perpendicular distance of B from the line of action of F through A. Okay, now by applying equal and opposite force F at B, the system of force is not disturbed. Hence, the system of force as shown in the figure B is same as that system given in the figure A. Now original force F at A and the opposite force F at B forms a couple of magnitude F into D. And the system in the figure number B can be replaced by system shown in the figure number C. Thus, the given force F at A is replaced by a force F at B and moment Fd. Okay, as we have seen previously, this figure number A is replaced by the figure number C, that is having the one force F as well as the couple moment F into D. Now let us see one example. A uniform wheel. Now this example what we have already seen. Now let us proceed for the new example. Find the resultant of system of coplanar forces acting on a lamina as shown in the figure. Each square has side of 10 millimeter. Now if you see here, there are the three forces which is acting over this lamina. One, this force is having an intensity 2 kilonewton and it makes an angle theta 1 over here. Now here the side of each square is of 10. This side is of 10. This side is of 10. All these blocks having the dimension of 10 millimeter. Okay. And another force which is passing from this point and intensity of 5 kilonewton, it makes an angle over here theta 2. Now another force 1.5 kilonewton which is passing from this point, it makes an angle over here theta 3. Now here from this geometry we can find out the theta 1, theta 2 and theta 3. Now let us see how to find out the values. Now if theta 1, theta 2 and theta 3 are the slopes of an force 2 kilonewton, 5 kilonewton, 1.5 kilonewton, the force with respect to x-axis, then now here tan theta 1, if you check it out, theta 1, this one is the side of 10 kilonewton, 10 millimeter. This one is the side of 10 millimeter. And tan theta 1 is nothing but what? Opposite side upon adjacent side. That's why this 10 divided by 10. It means that tan theta is equal to tan inverse of 1. Now if you calculate this one, now let us calculate this tan inverse of 10 by 10. 10 by 10. What you'll be getting? 45 degree angle. Okay, once you will have calculated the theta 1 value. Now next one, theta 2. Now to find out this theta 2, what we have to see here, this distance and this distance. Now measure this 1, 2, 3, 4. It means that this distance is of 40 because one block is of 10. Similarly over here, 1, 2, 3, 4, 40. Sorry, it has been taken over here. Once I will check it out. This distance opposite side upon hypotenuse, tan inverse. Now let us check it out. This distance from here to here, sorry, $14 from this to this. And this distance is of 30. That's why tan theta is equal to 30 upon 40. Now resolve this force and find out tan inverse 30 divided by 40. This value is 36.86. That is 36.87. And another one here, this value is of 10 and this value is of 20. That's why tan inverse 10 divided by 20. 10 divided by 20. You'll be getting 26.56. These are the angle what we have getting from this geometries. Now once you will be getting this value, next step, as we know that we have to resolve these forces in horizontal and vertical axis. Now let us see, resolve these forces horizontal as well as in vertical axis. Now here it makes an angle of 45. This one is the adjacent angle and the adjacent force. This will be the cos component. That's why 2 cos 45. This one is the 2 sin 45. Now here this theta 2 over here, opposite angle over here. That's why this component will be 5 cos 36.87 and this one will be 5 sin 36.87. Now similarly, here this angle is of theta 3. It means that this side, this angle also cos theta. That's why 1.5 cos 26.56 and this will be the 1.5 sin 26.56. These are the resolution of your forces. Now once this step is followed, as we know that the next step is we have to make the summation of x directing force and summation of y directing force. Now let us make the summation of x directing force. Summation of x, this force is going in the right side direction. That's why we are taking it as positive. 2 cos 45 is positive. 1.5 cos 26.56, this is the force going in the left side direction. That's why it is negative force. And this 5 cos 36.87, it is going in the right side direction. That's why it is taken as positive force. Now make the calculation. This will be the positive, this will be the negative, this will be positive. Make the calculation over here. 2 cos 45 is positive force minus this 1.526.56 is negative force and minus 5 cos 36.87. This is also positive force. Something went wrong. Now let us check it out. This cos term is missing over here. 1.5 cos 26.565 plus 5 cos 36.87. Okay, 4.072 kilonewton, and this force is going plus. It is indicating that the answer is plus. It is indicating that the force is going in the right side direction. Okay, the force is going in the right side direction. Summation fx. Now similarly, what we have to find out, summation fy. Now this force 2 sin 45 going vertically upward. That's why it is positive. This 1.5 sin 26.56 going downward, that's why negative. And this 5 sin 36.87 going downward, that's why it is also negative. Now write it down, summation fy. Now make the calculation. 2 sin 45, which is going vertically upward, minus 1.5 sin 26.56 downward minus 5 sin 36.87 downward. Now if you calculate this one, you'll be getting the answer minus 2.56 kilonewton. This force is going vertically downward. That's why answer is negative. It is indicating that the force is going downward direction. Force is going in the downward direction. Now once you have resolved these forces, we have found out all these components. Now next step is that we have to find out the resultant R. And as we know that the formula for the to find out the resultant force, R is equal to square root of summation fx square plus summation fy square. Put the values 4.072 square plus into bracket minus 2.26 square. Now if you solve this one, we may use the pole function. To use the pole function, shift this button, you'll be getting the pole value. Now 4.072 comma 2.26 bracket complete, you'll be getting the answer 4.66 Newton. This will be the value of your resultant force. Now the direction of your resultant force, that is indicating the let theta is the angle which is the resultant force makes with the your. Now if you see here, this summation fx is positive, that's why it is going in the right side direction. Summation fy is negative, that's why it is going in the downward direction. And resultant your lies at this quadrant number 4. It means that your resultant 4.66 kilonewton, and we have to find out it making an angle theta with the horizontal. To find out this, we have to draw the parallelogram. This value and this value will be same. That's why this theta is nothing but what? Opposite side upon adjacent side. Opposite side is of 2.26. That is summation fy divided by summation fx. Summation fy upon summation fx. Now put the values. Tan inverse 2.26. Now let us calculate this term also. Tan inverse 2.26 divided by 4.072 bracket complete is equal to. If you are making the round of values, the little bit answer may be varying, and 28.99, it is near about 29. Okay, your theta will be getting over here. It means that we have resolved the force as well as we have finded out the resultant R, the position of resultant R with respect to horizontal axis. Now we have to locate this. To locate this, as we know that these are the previously we have calculated the angle and these are the forces. But this resultant R, what will be the position with respect to this origin, that we have to find out. The distance, let us say distance D of the resultant from the O is given by, how to find out this distance, perpendicular distance O from the O to resultant R. To find out this, let us take the moment of all the forces about point O. Moment of all the forces about point O. That's why first moment is this resultant R into perpendicular distance, let us say D. This will the, as per the Varigno's theorem, what we have seen in the Varigno's theorem, the moment which is caused due to the resultant is same at about any point is same as that of number of forces producing the same moment. If we are considering this moment of this force and this force about point O, which is producing the same moment, which is caused due to the resultant R. Now let us check it out. Now this force, resolved force, which is passing from the point O, that's why we are not considering this force, because the perpendicular distance which is caused due to this force is 0. Okay, now the next one. Next one, this force. We may shift this force anywhere on the same line of action. Anywhere on the same line of action. If you check it out, this force, it makes an clockwise moment about point O. That's why this moment is positive due to this resolved force. And this force is passing from the point O, that's why the perpendicular distance is 0. That's why we are not considering this force. Now this force, on the same line of action, we may consider this force anywhere. I may resolve this force over here. I may resolve this force over here also. That's why we are shifting this force from this position to this position. Now again, this force, horizontal force, is passing from point O. That's why the moment which is caused due to this resolved component is 0, because the perpendicular distance is not equal. Now the remaining part is 1.5 sine 26.56. It makes an clockwise moment about point O. It makes an clockwise moment about point O, and the perpendicular distance over here is 10. Okay. Now similarly, this resolved component of this force, it is also passing from the same point O. That's why this component is not considered. The moment which is caused due to this moment force is 0, as similar to this one and as similar to this force. All these three forces are passing from the point O. That's why the perpendicular distance is 0 and moment is 0. Now the remaining one, this one, and it is also making a clockwise moment about point O, and the perpendicular distance over here is this distance is 10, 10, 10, 10. Count this one, you'll be getting 50. Now if you make this together, you'll be getting. Now here resultant R, the value of resultant R is 4.66, and the perpendicular distance what we have considered is, let us say, D. Now this first force component 2 cos 45, and the perpendicular distance 1, 2, 3, 4. It means that this value is 40. Now this component 1.5 sine 26.56, and the perpendicular distance is of 10. Perpendicular distance is of 10. This value, the distance is of 10. And for the first force, this perpendicular distance is of 40. It makes a clockwise movement. That's why this term is positive. Similarly, it makes a clockwise movement. That's why this term is also positive. And last one is also making a clockwise movement. That's why this force into perpendicular distance from this to this distance is of 50 into 50. Now let us solve this one. Now put the values. 2 cos 45, 2 cos 45 into 40 plus 1.5 sine 26.565 into 10 plus 5 sine 36.87 into 50. If you solve this, you'll be getting 213.27. Now this value divided by 4.66. What you'll be getting the D value, and D is nothing but what? This perpendicular distance is 45.87. Now if you solve this, D is 45.76 millimeter as shown in the figure. Now if you see here, to locate these distances, your resultant R is 4.66 and your perpendicular distance D is 45.6 millimeter. It means that due to these three forces, whatever may be the effect producing, the same effect will be producing by this single force, resultant force R, which is making an angle theta, that is nothing but what? The previously what we have calculated, 29 degree, with the horizontal having the magnitude of 4.66 kilonewton, and which is located perpendicular distance from point O is 45.6 millimeter. From the point O at a distance of 45.6 millimeter, having the intensity of 4.66 kilonewton, this magnitude of force at this distance is giving the same effect as that of produced by this number of forces. It means that what we have done, we have finded out this single force, we have finded out the location of this force by finding the distance as well as making an angle which is with horizontal. All these component and locations we have finded out regarding this resultant by using the method of resolution as well as the concept of moment or the concept of Varigno's theorem. Okay,